Hey! Our topic for this set of notes is segment addition! And our essential question is, how do I use segment addition to find the length of a segment? Oh, and there should be a question mark there. So let's have at it! Alright, first of all, we need to make a note about what is the segment addition postulate. Now, by the way, a postulate, P-O-S-T-U-L-A-T-E, is an if-then statement. It's a conditional statement that we just take for granted. We assume it's true, we don't question it. And the segment addition postulate says that if point C is between A and B, then AC plus CB equals AB. So notice if and then. And by the way, the word between has actually a very specific meaning. It means that A, B, and C are collinear. A, B, C, collinear. And that C is between in the sense that we would think of between. There's actually a much more complicated definition of that, but we're not going to worry about it. But when I say between, we're assuming that the 3 points are collinear. All right. And here, by the way, notice that we are looking at the AC and CB and AB with no lines over top. So we're talking about the distance from A to C and the distance from C to B added together equals the distance from A to B. And let's draw a picture of this just to kind of clear it all up a little bit. So here I would have A, and I would have B, and then somewhere in the middle we would have C. So the distance from A to C plus the distance from C to B equals the entire distance from A all the way to B. So how are we going to use this to solve a problem? Well, let's look at an example. Let's say, for example, that we had, and we'll just use A, B, and C again. And say we said that AC equaled 5, and I'll put a little 5 here. And say we say that CB equals, 9, and we'll put a 9 over here. And we were asked to find what is AB. AB equals question mark. Well, we'd set up our segment addition postulate, and we would say AC plus CB equals AB. We'll do some substitution. AC is 5. Well, here you go. AC is equal to 5, so we're going to replace AC with 5. We're going to say that CB is 9. Notice again, CB is 9. We're going to put the 9 down here. We are adding them together. Equals AB. 5 plus 9 is 14. Equals AB. And we're done. AB equals 14. All right. So let's take a look at another quick example here. Say, on the other hand, we had AB and point C, and we were told that AB equals, 17. And CB equals, oh, I don't know, 3. AC equals what? So here we're told that the entire distance all the way from A to B is 17, and then this little part CB, that's just 3. So what's the other part? So again, we set up our equation. AC plus CB equals AB. And then we do our substitution. We've got CB is 3. We've got AB is 17. And then AC, we don't know that. So AC plus 3 equals 17. I'm going to go ahead and subtract 3 from both sides of this equation. Move everything up a little bit. And we end up with AC equals 14. And we're done. One more example. Okay, so imagine now we've got A, B, and C somewhere. Oh, that should be A. And A, B, and C somewhere in the middle here. And this time we're told that AC equals x plus 3, and that CB equals 2x plus 5, and that AB equals 23. And we're supposed to find AC and CB. That should be CB. All right. So here we set it up. We start out the same way as we did before. Scooch these up a little bit. We're going to say that AC plus CB equals AB. We're going to replace AC with x plus 3. We're going to replace CB with 2x plus 5. And AB with 23. So next we're going to open these parentheses up and combine like terms. I've got an x and a 2x. That gives us 3x. And then I got a 3 and a 5. That gives us a positive 8. And then over here we've still got our 23. All right. So now we're going to go ahead and solve this equation. Let's see, I'll start by subtracting 8 from both sides. That gives us 3x equals 15. And then, okay, I'll move things up a little bit here. And then we're going to divide by 3 on both sides, and we end up with x equals 5. But we're not finished. Don't forget, we have to go back. Into our original set of expressions. And we've got AC equals x plus 3. And then we're going to substitute 5 for x. So AC equals 5 plus 3, or AC equals 8. And then we've got CB equals 2x plus 5. And we'll go ahead and substitute 5 for x. 2 times 5 plus 5, and we get CB equals 10 plus 5, or CB equals 15. And just as a double check, we go back and we could check here. Let's see, 15 and 8 equals 23, and sure enough, AB is 23, so it worked. So I did want to make a note here make a note here that we should say step 1, set up equation using segment addition. Step 2, solve equation. Step 3, substitute solution into original expressions. And finally, step 4, oh, that should be a 3 there. Step 4, check answer. Does segment addition add up, for lack of a better term? All right, good work.